Hello everyone. Let's describe a situation. Suppose you are sitting inside a stationary car and you observe that rain is falling vertically downward to the ground. Now, as soon as you start to move, then you will observe from the car that rain is falling on the ground or on the car in an inclined direction. In this moving situation only, a person standing on the ground, stationary person, will observe that rain is falling to the ground in the vertically downward direction only. Now, what we have seen here is that the direction of rain is different for different observer. For moving observer and for stationary observer, the directions are different. In fact, the magnitude of the velocity at which the rain falls are also different. Now, why does it happens? We will describe this through this video. Let's understand. You see, the physical quantities, all the physical quantities are measured with the help of frame of references. What's a frame of reference? Frame of reference is nothing but a coordinate system with the help of which we measure the physical quantities like velocity, force, displacement, acceleration, etc. Now, this frame of references can be fixed frame of reference, can be moving frame of reference. Normally, when we want to measure the value of the physical quantities, we take the fixed frame of references, and this fixed frame of references or moving frame of references are associated with observers or objects. Let me take the case of velocity. For example, a car is moving with 50 km per hour. We understand that the car is moving with 50 km per hour with respect to some fixed frame of reference. That fixed frame of reference can be ground or can be a person standing on the ground with whom a frame of reference, which means the coordinate system, is associated. Let's take the case of two cars, car 1 and car 2. Car 1 and car 2 both are moving with velocities 50 km each, and these 50 km velocities are measured with the help of a frame of reference which is fixed, and that frame of reference is associated with an observer, stationary observer. Now, what's a velocity? Velocity is nothing but the amount of distance an object can travel in unit time. It means this person is measuring the amount of distance traveled or displacement traveled by the cars in unit time. Now, for both of them, in this example, I have taken the equal velocities and it is 50-50. Now, if I want to have an experiment where the velocity of car 1 has to be measured with the help of a moving frame of reference or with the help of the moving car number 2. So in this situation, what I will do, I will associate a frame of reference with car 2, and I expect that the car 2 will measure the velocity of car 1. Car 2 will measure the amount of displacement traveled by car 1 in unit time. That's what I mean. Now, the velocity of car 1 as observed by car 2 will not be 50. Why? Because velocity of car 1 was 50 with respect to a fixed frame of reference, because the car 1 was moving 50 km in unit time. But with respect to car 2, the car 1 is not moving with 50 km in unit time, because car 2 is also moving with car 1 in the same direction. Therefore, when we attempt to measure, or when car 2 attempts to measure the velocity of car 1, then car 2 has to subtract how much distance that car 2 is also traveling along the direction of car 1. Then the amount of velocity or amount of distance travel in unit time by car 1 as observed by car 2 comes out to be 0. So we have seen that for moving observer and for stationary observer, the velocities are different. So velocity depends on what? The observer or frame of references. So what we have seen in this example is that To measure the velocity of car 1, we have to subtract the velocity of car 2 if the car 2 is measuring the velocity. Okay. Now you see the velocity is a vector quantity, and both the objects whose velocity we want to measure and the object who is measuring the velocity can have different directions of motion. In this example, the directions are same, but they can move in different direction. Let me take two objects and let me describe the general case. Object B and object A. For example, object A is moving along this direction and object B is moving along this direction. Therefore, if I want to measure the velocity of object A as measured by the object B, then in the proper vector format, I will write it like this. In this, at this point, I assume that viewers are acquainted with the vector algebra, vector addition, vector subtraction, and vector product. And you can also check the link of vector video in this channel. Now, the velocity is a vector quantity. It has magnitude as well as direction. So whenever vectors are given in proper vector form, for example with I cap j cap, then only we can use this formula. Otherwise, we have to use the magnitude formula. So vector algebra gives us the magnitude of this vector as this one. So magnitude of the vector VAB. What is VAB? It is the magnitude of the velocity of A as measured by observer B or object B. And this velocity, we see it depends on the direction between the objects, motion of the objects. The direction of between the motion of the object is described with the help of the quantity called the angle between the vectors. Now for different angle, the magnitude of the velocity will be different. For example, if both the objects are moving in the same direction, then the angle between them will be 0, and the magnitude of the velocity of A with respect to B will be VA minus VB. In the similar line, if they are moving in the opposite direction, then it will be VA plus VB. And if it happens that they are moving in the perpendicular direction to each other, then it will be square root of VA square plus VB square. And there can be different cases or different kind of form depending upon the angles. These three are the standard ones. Let's consider few questions. In this question, the question describes like this. A car is running with the speed of 15 meter per second, observes that rain is falling on the windshield of the car with speed 30 meter per second. The question is at what direction and speed the rain is falling on the windshield as observed by a stationary person. So as we understand the situation, it is like this. Let's say car is moving like this along this direction and rain is falling vertically downward direction. I consider there is no wind. Now this is my car and this is my rain, and these are the directions of rain and car with respect to fixed frame of reference. So velocity or the magnitude of the velocity is equal to 15 meter per second, and magnitude of the rain with respect to ground, it is not given. But while the car was moving, then the car observes that rain falls on the car in an inclined direction, and that direction is 30 meter per second. How do we know? Because question mentions that the car observes the rain falling with 30 meter per second while it is moving. Okay. Now the question is at what direction it is falling. To calculate the direction, we have to calculate the angle, this angle, and from the geometry we know that this will be the angle theta. So it's a right angle triangle. So if we can write this velocity, by the way, the velocity of rain with respect to the car, so this will be v1 divided by v21 to be equal to sine of theta, and from here theta comes out to be equal to 30 degree. So this angle is 30 degree. Or if I want to find the direction with respect to the ground or direction with respect to the motion of the car, I have to add 90 degree. So this will be 30 plus 90, which will be 120 degree. So rain will be falling on the windshield at an angle 120 degree with it. Next, what is the velocity of the rain with respect to stationary observer? So we will simply apply the case number 3 or the simple Pythagoras theorem. So v2 square v21 is equal to v1 square plus v2 square square root, because both the velocities are 90 degree with each other. So from here when we put the values, so this will be my 30, this is equal to 15, and this is the value that we have to find. And we observe that this is equal to 900 minus 225, so this will be 675. So v2 will be equal to square root of 675, so this will be 15 root 3. So answer will be option B. Let's proceed to the next question. This question describes that two objects A and B are moving with velocities VA and VB, and we are supposed to calculate the magnitude of velocity A with respect to or related to velocity B. So these data are given in proper vector form, that means I cap j cap form, so we will not have any problem. So we can directly use the proper vector formula. We have to find the velocity of A, so I will write A first with respect to B. So velocity of A I have to find with respect to B, therefore I have to subtract the velocity of B here. So this will be 20 minus 6 j cap minus 4 I cap plus 6 j cap, and then 16 I cap minus 12 j cap. But we have to find the magnitude, and thereby the magnitude of the vector will be equal to 16 square plus 12 square. This is famous triangle. This will be 20 meter per second. That's the answer. Let's move on to the next question. So here in this question, the situation is described as there are two trains, and both the trains are 50-meter long, and they are traveling in opposite direction with velocity 10 meter per second and 15 meter per second. The time of crossing is something that we have to find. So suppose this is one train, the object 1, okay, and let's say this is the train number 2. This is the train number 2. Let's say this is moving with velocity 10 meter per second, and this is moving with velocity 15 meter per second. They are moving in the opposite direction. Since they are moving in the opposite direction, let's say this is A, this is object B. So velocity of object A with respect to B, since they are moving in the opposite direction, this will be equal to VA plus VB. So relative velocity of object A will be equal to 25 with respect to B. Now you see, we have to find the crossing time. How much time any of the train would take to cross the other train. So I'm just considering the object A. So object A starts crossing at this point, and then when the object A arrives here, the crossing is over. So how much distance the object A has traveled? This much plus this much. So the total distance the object A has traveled is equal to 50 plus 50. This is the crossing distance. So since the velocity is constant, I will use this simple equation of motion, uniform equation of motion. So this will be my 100 equal to 25 multiplied by t. So t comes out to be 4 seconds. So that's the answer. Let's move on. The situation described in this question is as follows. There are two blocks, and the question says that the block P is released from the point A of a smooth inclined plane, smooth surface, that means there is no friction, and the height of this plane AC is 20 meter as given, and we have another block Q moving in the horizontal plane, smooth plane, with velocity 10 meter per second, and we have to calculate the magnitude of velocity of P when it reaches the point B with respect to block Q. So basically, when the question is when the block P will be here, then what will be the velocity of P with respect to this Q? So when the P will be here at point B, so first of all, what is the velocity of that? Let's say that velocity is V2. Now this velocity, from simple kinematics we can calculate that this is equal to square root of 2gh. I'm not going to the details of this calculation, or I can also calculate this with the help of conservation of energy, or well, let's say any kinematics equation, v square equal to u square plus 2as, since this height is given. So this is square root of 2gh, and I can calculate this 20, and the velocity comes out to be 20 meter per second. Now we see that if I draw it here, the P is moving like this and Q is moving like this. What is the angle between them? This angle will be 60 because this angle is 60, so this angle will be 60. So what is the velocity of P with respect to Q? So I can use this formula, since we need only the magnitude, cos of 60. So this will be equal to 20 square plus 10 square minus 2 into 10 into 20 into half. So this will be equal to 400 plus 100 minus 200. So this will be equal to 300 square root, or this will be 10 square root of 3 meter per second. So that will be the answer, option A. Let's move on. So here in this question, the situation is described as follows. There are two particles again. Particle A, it is moving along x-axis with uniform velocity, and the velocity is 10 meter per second. The particle B moves with uniform velocity 20 meter per second along a direction, making an angle 60 degree with the positive direction of x. The question is, what is the relative velocity of B with respect to A? Relative velocity of B with respect to A. So simple question. So first of all, we have to find the direction also. So this is the velocity of A. If I were to draw it here, let me draw it here. This is the velocity of A, this is the direction, and this is the velocity of B. Now see, whose velocity I have to find? I have to find the velocity of B with respect to A. So I will write down this vector. So I have to subtract the velocity of A. For that purpose, I will draw minus VA. This is my minus VA. And then I will join this line from the initial point of B to the final point of A. This will be my VBA. So the direction of the velocity, direction of velocity of B, or direction of relative velocity of B with respect to A will be towards x-axis, sorry, y-axis. This will be y-axis because this is defined as x-axis according to the question. Now, what will be the magnitude of this velocity? Angle is given, it's not a problem, we can calculate. So this will be VB square VA square minus 2 VA VB cos of 60 degree. So this will be equal to again 20 square plus 10 square. So 2 into 20 into 10 into half. I think again the same kind of answer will come, 10 square root of 3, and I think the option will be this one, along x-axis. Let's understand this question. According to the question, a ball A is thrown up vertically with a speed u, and at the same instant another ball B is released from a height h. At any time t, what is the speed of A with respect to or relative to B? So let's describe the situation as follows. This is my A, and it is thrown with the initial velocity u. It will move up. Okay, then from a certain point the object B is released. Now at any instant, let's say this is my object B. At any instant, this is the velocity of object B. At any instant, this is the velocity of object A. And I have to find at that instant what is the velocity of object A with respect to B. I can see that both the velocities are opposite to each other. So velocity of object A with respect to B will be what? VA plus VB. Now the question is, at that instant what is VA and what is VB? So at any instant what is VA? Remember, u is the velocity of A initially. After a time t, the velocity becomes VA. So what will be that? I can use the equation of motion. Let me use this equation. So final velocity I have considered VA, initial velocity is u, g is minus. So this is the velocity at any instant VA. What is the velocity VB at any instant? Same equation I will use. Final velocity, initial velocity, acceleration time. The object B is released, that means initial velocity is 0, and VB will be minus because this is downward. So 0, G is always minus. So at any instant VB is GT. So I will put it here. So U minus GT plus GT. So the answer will be equal to U. I hope this is clear. I urge you to try these questions as homework, and please paste the answer on the comment. Thank you.